Hi everyone, my name is Helen and welcome to the Sustainability Masterclass on climate change. I would just like to start by mentioning that I know climate change is presented as a contentious issue in the media, but it isn't. The science is clear-cut. There's an overwhelming consensus among scientists, and as the data continues to pour in, climate change has become irrefutable. Overall, 97% of scientists agree that humans are causing climate change and global warming, and most of the leading scientific organizations around the world have issued public statements expressing this. This includes international and American academies of science, the United Nations, and the Intergovernmental Panel on Climate Change. So today, I'm going to walk you through the scientific case for climate change so that you get a bottom-up understanding about how all of this works. Our atmosphere, or the thin blue line as seen from outer space, is what separates our planet from others. That's what keeps our planet at a habitable temperature and also makes sure we have oxygen to breathe. But the problem is that we are changing the composition of what makes up the atmosphere. So how is this happening? This is the global carbon cycle, and as you'll see, a lot of this cycle is natural. The natural carbon cycle works like this. Every year, we have carbon from our atmosphere that is taken up by biomass, soils, and oceans. And when the biomass respires or dies, it releases carbon. The ocean also respires and releases carbon to the atmosphere, and this goes in a cycle. When we do the math of what gets taken up from the atmosphere and what gets released to the atmosphere, this cycle is in balance. However, over the last 100 years, we have begun to interrupt this balance heavily. And what is interrupting this balance? Oil. Now, there are other things as well, but we're primarily talking about fossil fuels here. It's important to point out that the amount of carbon on this earth is not changing. It is just being moved from one place, buried deep in the Earth's crust, to the atmosphere. But if we do the math, it simply doesn't add up. We are releasing more carbon to the atmosphere than the planet can absorb. We simply don't have enough biomass or ocean or soils to take the excess up. So what happens when you add a bunch of carbon dioxide and methane from fossil fuel burning and land use change to the atmosphere? Well, we have more of these heat-trapping substances in our atmosphere and thus more warming. Different greenhouse gases have different warming capabilities. These molecules have the ability to trap heat, and this is actually a good thing at the right level. That's what keeps our planet warm enough to live on. Methane, for example, has 34 times the warming potential of carbon dioxide at a time horizon of 100 years. And N2O has 284 times the warming potential of CO2. However, it is important to point out that we cannot adapt to any temperature rise above 2 degrees Celsius. The science behind this is robust. So how much warming do we expect? Well, with business as usual, we expect between 4 to 5 degrees of warming within the next century. With that, I would like to say thank you for watching, and until next time, thanks.